Kia ora and welcome to my video explaining the theory behind differential leveling. For this technique, we'll be using an auto level, also known as the dumpy level, to find the difference between 2 points. The theory revolves around the assumption that we're able to take measurements relative to a level line, shown as the dashed line. This is parallel to our datum line at the bottom of the screen. If we were to put a drop of water on the dashed line, it would not flow left or right, but stay right where it is. This is because the line is perpendicular to gravity, meaning there is no uphill or downhill. The dumpy level is designed to look along this line very accurately. It does this through the use of a compensator, which we'll learn about in the observations video. So let's bring in a couple of points in our leveling staff. You can think of the staff as a giant ruler, because that's exactly what it is. We'll learn how to read it in the observations video. The measurement we get from the staff tells us the distance from the level line to the point at the base of the staff. We call this measurement the back sight. Next, we put the staff on the other point and measure from the level line to the point. This is called the foresight. Using these two measurements, we calculate the difference in height between 2 points. The formula is remarkably simple, just back sight minus foresight equals our change in height, or DH. And that is the theory in a nutshell. And that's all well and good, you say, but what if we can't see between the 2 points we're interested in? That's when we start traversing. To traverse, we observe and calculate the height differences between a whole series of points. Normally our first back sight will have a known height relative to a datum, usually a Council or Linz benchmark. This means that every point in the traverse can then be brought into terms of the datum later on. The subsequent points in the traverse are known as change points because this is where the dumpy level changes position. It's very important that the staff remains on the same point as the dumpy level moves. At this stage we could calculate a height for the top of the hill, but we'd have no check on our data. As surveyors, we need to guarantee our data is correct. So to check our measurements, we have two options. We could look back to our original mark and check the measurements against themselves, or find another mark with a known height above the datum and check our measurements against the datum. This is the preferred option. Luckily for me, there's another benchmark right here. Once I've closed my traverse at the final benchmark, I'll calculate a total difference in height between the two benchmarks. The downhill portions of the traverse should be treated as negative numbers so that they cancel out the positive uphill numbers. We'll call this number D total. Now, because our benchmarks both have known heights relative to a datum, we can calculate a difference between them using these heights as well. We'll call this number D control. In theory, D control and D total should be the same number. However, the world is rarely perfect and you'll find that there is usually a small difference between the two numbers. It should be in the realm of millimeters. The difference is called the misclose, and so long as this number is smaller than our allowable tolerance, we can assume that our measurements are correct. That's it for this video. If you'd like to learn more about taking readings and how the level works, check out the observations video. If you'd like to see the gear in action, check out the leveling procedure video. If you just want to geek out over the maths, go dive straight into the reductions video. Sure.